Thank you very much, Vera, for kindly accepting our invitation for this interview for the CEIS20 podcast. It is our pleasure to welcome you to this platform where we try to disseminate the work of our colleagues, collaborators, and people who work on a range of topics, especially if they focus on interdisciplinarity or they touch different aspects of disciplinary domains. So, warm welcome to you, and we would like to start by asking you, that if you could tell us a bit about who you are and your background, and what sort of your research focus, your main research focus is, and a bit of your research trajectory.
Great. Well, thank you. Thank you for the invitation. It's a pleasure to be here. So who am I? My name is Vera Aldeias. I was formed initially as an archaeologist here in Portugal, University of Lisbon. And then I became very interested in geology, and geology applied to understanding archaeological sites. So I did my PhD at the University of Pennsylvania in the United States. And then I did my postdoc, my first postdoc in the Max Planck Institute in Leipzig in the Department of Human Evolution. And I am now a researcher back in Portugal at University of Algarve at the center called ICArEHB. And what I do is that I try to understand how archaeological sites form. So I apply not only archaeology, but also geology, geochemistry, to understand the formation processes behind the sites, how well the sites are preserved. And I'm also very interested in studying sediments that were made by humans. So this, what we call anthropogenic sediments, and studying them to reconstruct past human behavior.
Well, that's fascinating, very interesting. I would like to know, maybe, as a segue to this, you mentioned the formation of sites, and that's what you're trying to study, which I think sends us to thinking about, when were those sites first inhabited, or at least when is the record of those sites first visible in the present day. So is there any specific aspects of the archaeological sites that you study that you would like to, tell us a bit more about?
Well, the thing is that in archaeology, when we retrieve data, we retrieve it by excavation, right? So by taking the sediments away. And traditionally, this was used as a means of chronology before we had absolute chronology to say what came before, what came after. But nowadays that we have other ways of doing chronology, it's very important to understand how sites form, because it's not what we see at the site today is not necessarily how the site was left in the past. Things move, sediments move, artifacts within those sediments can be mixed together from different ages, and etc. So what I'm interested in doing is reconstructing this integrity of the archaeological layers and archaeological assemblages. But more than that, we can also reconstruct the environment at the time of occupations. And now, because we can retrieve a lot of information from the sediments, from this, what we call the invisible record that we cannot see with our own eyes, but is stored in this sedimentary matrix, we can do much more about understanding human behavior through studying the sediments themselves, instead of just sieving them away in an excavation. And this is a part I'm very interested in, and retrieving this kind of behaviors that are preserved in the microscopic or molecular level scale in sediments, and we can actually now start to peel out this information from archaeological sites.
Yeah, that's fascinating, because at least myself, right, we tended to think about archaeology as this sort of like big sort of macro scale enterprise, right, with digs and people with shovels, and but you're actually taking that to the microscopic level and looking at sediments to understand human behavior. Can you give us some examples of the types of human behavior that you're sort of trying to uncover from the sediments, and I guess the transformations in human behavior that you're interested in?
Yes, sure. So one of the examples, for instance, I've been working for a long time now, is to understand when humans start to use fire. And so fire, when we do a campfire, we produce sediments. And these human-made sediments, or we can call them anthropogenic sediments, are better studied if you apply a geoarchaeological perspective, which is what I'm interested in. So I've been working a lot in understanding the evolution of fire as a technology. For instance, in Neanderthal sites, how did Neanderthals actually use and control fire? And also in the first Homo sapiens arriving in Europe, studying that. And even in Africa, I also worked a bit in Morocco, studying first Homo sapien occupations at the sites that were using fire. So this is a type of segment in behavior. It's like a snapshot of behavior, because you don't do a fire for hundreds of years, right? You do it for a couple of days, a couple of weeks, months maximum. So really looking at that, those sediments related to fire and combustion really gives us snapshots of activities of these populations. How were they controlling the fire? How were they making the fire? Where were they positioning the fire? And to try to understand a bit about function and activities surrounding those fireplaces back then.
Yeah, that's amazing, right? Because fire really takes us to this. It's one of the unique behaviors of humans, right? The control of fire. And so, are there? I mean, when you mention Neanderthals and other human groups that are now, seemingly extinct or regarded as extinct, let's not go into that. But do you see, in terms of fire and the use of fire, the control of fire, are there any noticeable differences between these groups that you can sort of see in the archaeological record?
Yeah, so the research with fire is exactly what you said, because it's such a trait that makes us human, that we use fire the way we control and produce it at will like no other animal. A lot of the research has been focusing on the first appearance of fire. When did we start being able to do fire? And there have been a lot of discussions on this, and they're not easy to trace back in time because they are very sensitive, delicate sediments that are easy to be lost through time. But then another research that we've been working on more with Neanderthals, for instance, is to see when do they have fire and when do they don't have fire. So we have worked in sites in Southwest France, where in two sites a very peculiar pattern evolved, that during cold glacial times, there were Neanderthals occupying these sites, but there was no fire associated with these occupations. And this kind of work has been very contested of why don't they have fire? Is it just because we lost them, or are they truly not making fire? So there's been a lot of push to understand Neanderthal fire technology in the last 10, 20 years. And what we know about Neanderthal fire technology is that they do use fire. Maybe they don't use it all the time. This is something I think it's still very open to discussion. They may have other adaptations at certain places, certain times, that can bypass the need for fire. But we know they're doing this kind of very open combustion features. They don't do a big construction on fire features. They can do some pit hearths. There's some examples of that. They have some management activities, like they can clean up a hearth, have areas that they dump their ashes, for instance. And when you compare this with early modern humans, which is something that's very unexplored, we just did some research on this recently, but there's a lot to do. But what we see with early modern humans is that very early on, say with some of the first Homo sapiens arriving in Europe, associated with the Aryan nation, you already have some examples of very constructed fireplaces. So there are these fire pits, sometimes dug into the bedrock in some sites, for instance, also in Southwest France, whereas Aurignacian populations in Greece, and some sites there, they have actually produced these clay bases that they use as the base where they do a fire on top. And this is already very different from Neanderthals. It doesn't mean it's better or worse. I'm just characterizing it as different. And we've never seen any kind of this kind of fire technology with Neanderthals. It's a bit more simple fires, which, of course, Homo sapiens continue to also do this open flat hearths. But there is a lot of traits and nuances here with fire and how fire technology evolves through time that I think are going to give us some surprises in the future when more research is done. And we are just at the brink of starting it to do it more wide scale.
Yeah, this is really, it's sort of, it makes me think a lot about my own research, right? And sort of these transitions and what we call different populations, and the fact that they have met, and we know they've met, and they have interbred and had, offspring, and very likely prolonged periods of shared culture and family units and so on. So it's what I think, what comes to my mind when you were just describing this is that, and you've mentioned this, right, that we're only starting to look into this transition in between Neanderthals and modern human populations in Europe and in their use of fire. But what comes to mind is like, what is your expectation, right, going forward, if you have any? What is your expectation regarding these new ones you've mentioned towards the end, in terms of like, adoption or, for example, modern human type of fire control by Neanderthal populations, right? So instead of just looking and say, okay, so Neanderthals use this very sort of specific type of modern humans use this very specific type of fire and the way they control it and the pits, and they were more circumscribed and so on. Do you have expectations that, one day we see that Neanderthals, upon those encounters, might have actually borrowed some of those techniques themselves?
I don't know if I have expectations, but it wouldn't surprise me, right? So I think when we do these comparisons, we always compare with a sample number of one, which is our species, right, that we exist today.
Right.
So we always assume that our way is the best, but that's not the case. And it's really, for me, unreasonable, in the field that we always say, because it's different, is not as evolved or intelligent or smart. And I think that's a very poor way of conducting this kind of comparisons or science in general. I think it's very difficult for us to perceive a different species or different populations, different groups of humans that are not us, because we don't have a comparison. And what I mean by this is that I don't think I have so much expectations in terms of presence, absence, or a big departure necessarily, but it's, for me, always a matter of degree. So there's a lot of things that, say, Neanderthals were already doing sometimes to a lesser degree. What we see, or what I believe that we perceive in archaeological records for the data we have thus far, is that modern humans do it to a much bigger degree. So it's like a continuum for me, right? It's not presence, absence, one has, one doesn't. Often I think is way more about the frequency of doing it, the degree of complexity of doing it. And in terms of fire features, I think Neanderthals had complex fire technology, but modern humans have way more complex fire technology within that spectrum, and they have variability very fast, if you think about different populations. So our Aurignacians does this, maybe Gravettian populations later on do something completely different. Whereas in Neanderthal, I think you have a more slow degree of variability and degree of change. For thousands and thousands of years, it's very simple type of technology that is continued to be done because it works, right? There's no need to change it. Right. Whereas for me, that's the big difference. So it's not presence absence. I always have a very hard time with that. And if now we discover that sapiens and Neanderthals learn from sapiens and they are using it, I find that completely possible, right? I wait for the data to show it. But that wouldn't surprise me. But the degree in which we sapiens do things and the way we manage technology, the way we change quickly, I think that is a departure.
Yeah,
if that makes sense. Does that make sense?
Of course, completely. And I fully agree with you, right? That this idea of sometimes complexity being seen as, better or improved or, superior in some ways actually reflects a lot of the, views that I think are not warranted anymore, right, in our field. When we think about human evolution, the study of the human past, right, we're not really, I guess, most of us at least are not driven by those ideas anymore. Mm-hmm. My question was more on the borrowing of culture, and it could be the other way around, right? I can totally picture, the possibility that modern humans, in fact, inherited some of the techniques that Neanderthals used, being it in fire or, stone tool usage of any other type of, cultural material. Even I can, even imagine like religion and other cultural features being borrowed between populations. I would have no difficulty in conceiving this at all. But you've mentioned, So, but what it's interesting to me is like how these are cultural traits, right? These are cultural traits, and oftentimes they are mistaken by some sort of bioessentialism. That just because something is different, then therefore these populations were biologically better or improved or more intelligent or whatever is the explanation, which I think it's why we need dialogues across the disciplines, right? We need we need the archaeologists looking at the fire to tell us, like, really, wait, this is just different. As you said, not necessarily better or worse or whatever. It's different. It has these characteristics.
Exactly.
And
yeah, I
the
think
bio,
it's very
yeah,
yeah. I was
go
just going
ahead.
to say I think it's very interesting, this period of transition, and there's a reason why for hundreds of years we've been not 100 years, but more than 100 years now of research, we've been looking why Neanderthals disappeared, right? This is something that's really catchy. And now that we know there's other forms of humans around, it's really interesting to see how these interactions were. So you, from the genetic parts, can see that there were interactions, but why and how? That's from our archaeological side that can also contribute. And I agree with you, it's this dialogue that really helps us to understand these really periods of transition, especially because they don't last long, right? They are fleeting moments in terms of the way we have our record, which is a geological record. So say that it's 10,000 years, 10,000 years, that's very short time period for accumulation of data. So we really need to look into these time periods with all we got, you know, the macro, the different disciplines, but also the different interdisciplinary takes on the data we have, but also looking at different scales of observation to be able to really understand interactions one way or the other. And I agree, we still don't know much about these interactions, particularly if some of the cultures or the traits of adaptation of, say, sapiens passed to these late Neanderthals. I think we know very little about that.
Yeah, no, that's fascinating. And I think that our hubris will be defeated once again. We have more data.
What?
Our hubris, right? You know, our sense of being
yeah.
special. Because I mean, Neanderthals and other populations, right? Homo erectus, and I mean, these are groups that survived for hundreds of thousands of years, extremely harsh conditions, glacial, fluctuations, and so on. So, they knew very well what they were doing, I guess.
Yeah, they were clearly well adapted.
Yeah, absolutely, right. But this is, I guess, my next question is a bit more on the importance of interdisciplinarity, because we've been talking about, your research in particular and how you go, at the microscopic level, even to study archaeological sites. But we look at the implications of this work, right, in terms of our understanding of human culture. And so what is interesting to me is how the need that we have to explain the human past, right? We're not necessarily interested in just a very tiny sort of explanation about fire. I mean, we are, but we are also asking, what are the implications for understanding of becoming human, right? Of being here. What's the implications for our story? And that, of course, requires, as we were discussing, the intersection between disciplines. So my question to you is, like, how is your research like interdisciplinarity in that way? How many times are you sort of forced to include the perspectives of other disciplines into your own research?
Yeah. I think I'm lucky that all the time I feel fortunate to have interdisciplinarity. So as I said in the introduction, I am originally an archaeologist, which in Portugal is connected with humanities and with history. And because, for instance, I became interested in the geology part, I already went to do my PhD in Earth and Environmental Science department. So that already was a departure from the normal say one field, one way of looking at things. So that's already a bit, I think, substantially interdisciplinary within my own research, that I do geology, a bit of geochemistry, but also archaeology. And then I think in archaeology, particularly when we talk about prehistoric archaeology, maybe because our data is so hard to interpret and to extract information from it, we are very lucky that we do these interdisciplinary teams all the time, right? So we work with people that work more in botany. We work with a normal archaeologist that looks at, say, stone tools, but we work also with the zoo archaeology, looking at the animal bones, with the geologists, then people looking at, I don't know, like data of physics, for dating, And then now we have the geneticists. So that too is, I think it's a great add-on. And in my own research right now, I am the principal investigator of a grant, an ERC grant, that really pushes me into the interdisciplinarity aspect, because in this grant, we are looking at the sediments connecting to ancient DNA. So how the sedimentary ancient DNA preserving the sediments. Now, I am not a geneticist. I'm a geologist, archaeologist. So I look at the part of what are the sediments that are there? Are they preserved? Did they move? And then because I have a team of my colleagues, mainly geneticists, but also some colleagues working in ancient proteins, we try to combine our expertise into this interdisciplinary perspective to understand this sedimentary ancient DNA, and if it's in situ or if it moved.
That's so cool. I'm a bit jealous in a very positive way. Yeah, so I mean, it's interdisciplinarity is this thing, to me that, it's driven by questions, right? So you have the questions, and then at some point you're forced to communicate with others, right? Because there's no simple answer often for the questions we're posing. And I guess the reconstruction of the human past, which is really what we're doing, requires multiple lenses, right? Because genetics can be very, very useful and very direct, for example, to look at, patterns of relationships between individuals. But then if you just have that without any contextual information, it becomes very dry. I guess it's the same for a radiocarbon date. It's the same whether, if you have a fire,
but it answers different questions, right? So genetics is, you can say that, yes, people moved, right? You can show that very clearly, but you don't know how or why. Right? You cannot answer that. Yeah. And that's a different perspective, for instance. Yeah.
Right, absolutely. And then, but let's say that, they moved, but there were favorable corridors on where people could move. Right? So you need environmental reconstructions. Exactly.
Right? Yeah.
Right. So
the story comes to, it's a puzzle, right? It's a puzzle. And
exactly
every little piece needs to be put together, and not one piece is more important than the others. Yeah.
And I think the ERC really tries to get at this, that they want people looking for, answering questions that, require multiple disciplinary lenses. So can you tell us, like, now we touched upon your ERC grant and in the work you're developing at the moment in Algarve, this is in an international collaboration, of course. Can you tell us a bit about the future? What are your future sort of like perspectives or goals towards this research?
So my research here is really looking at, I kind of touched upon already with you, but at this period of transition, this very fleeting moment, especially geologically speaking, I like to call it as a blink of an eye, right? This time period that you have Neanderthal disappearing and sapiens arriving in Europe. So the ERC is focused on that. And because there's not much time, there's not much depth of sediments, right? Because accumulation of sediments needs time. So now we're talking about very short little layers in archaeological sites that are not very thick. So we're looking at those and looking at the sediments in those deposits to try to understand that transition, and then combine that with a lot of this research you now have with molecules that are present in the sediments. So DNA, of course, is the most relevant and most promising of it, because we can retrieve sediment HDNA. So the idea is to retrieve it within very highly contextualized areas that I understand how it formed. We try to understand the sources. And within this work of geology, sedimentology, geochemistry, and DNA, my future with my team here is also to do a lot of experimental work, baseline work, to see how actually ancient DNA interacts with different minerals in different processes, because we want to see, say, did it move since the deposition? So we're doing a lot of this, what I call baseline experiments, to put DNA into a sediment and then put those experimental sediments into a set of conditions, say like freeze thaw or heat applied to them, to see what's the threshold for preservation or movement of DNA. And then I'm also looking at, with colleagues, at the proteins. So can we actually extract ancient proteins from these layers? And finally, to look at the bioenvironment, so looking in terms of lipids or other kind of indicators like phytoliths, etc., that can give us some idea what was the environment. And with all of that, trying to understand, how and who that decides and how did they disappear? What was the environment they were living? Did that have a correlation at any sort in terms of this transition? So the future is a lot of sites that I'm working on. So in terms of geographically speaking, is very broad. The sites I'm working on throughout Europe. And then the detail itself is experimental and very little sampling, micro sampling of sediments to try to get information about the last Neanderthals and first Homo sapiens in Europe.
Well, this is really, really incredible and cutting edge. So, I really look forward to see the results of
Me
your
too.
work. No, I can imagine. But thanks so much again for showing us like a beautiful example of how interdisciplinary research can actually help us understand complex and contemporary questions at the same time, right? Because even if we're talking about hundreds of thousands of years or tens of thousands of years in the past, which is the case, then it's a very contemporary question, right? Because we keep trying to understand how we got here and what makes us human. So thank you so much, Vera, again for participating in our podcast, and we'll hopefully do this again at some point to discuss.
So.